So let me continue from here. So this is the GitHub site of Keras by Minas Palasara, and he has also given a good example to start with. So you install it in your environment, new environment which you have created, and you see in the examples, if you go to examples, there is a Python script named shapes3dcnn.py. So this is the program that we are going to run for our 3D convolution neural network. So you can directly copy this file into your environment, or you can copy this and make a new script and use it. So in this my project Keras CNN tutorial, I have got shapes3dcnn.py. So this is the code, and he has also given a data set, a 3D data set. So if you go here, Keras, and you go to Keras and then the data set, so you see shapes 3d.py. So he has created two shapes, okay, two 3D shapes. One is, I think, what is that, sphere or cylinder, I guess, or maybe it's a sphere and cylinder. You just look into it. Okay, so this is the data and this is the code. So first we are going to import that data, 3D shapes 3D. Then we are going to import all the necessary, the sequential model, the dense layer, dropout layer, and then this time we are going to import a convolution 3D and a max pooling 3D, and this is your optimizer, and this is a Theano. So this is a he's splitting, giving a 20% split between his, among his data set for training and test. This is the path size, means the size in third dimension, I mean the temporal dimension, you can say, number of frames that he will be going to use. So in this code he's splitting it, this data, he is giving a split test of 20%, and is splitting in training and test data. Then let me run this and show you. So let me first import it and see. Okay, so it will take some time to import, and he is using a batch size of 10 examples at a time, and there are only two classes, and he's using 100 epochs, and this is to convert in one hotkey format. And number of filters he is using in the first convolution, he has used actually two convolution layer. In first layer he will be using 16 filters, in second layer 32 filters, and the size of pooling is 3 cross 3 cross 3 in each cases, and size of convolution is 7 cross 7 cross 7 in first convolution layer, and second convolution layer is 3 cross 3 cross 3. So okay, it's taking some time. Okay, no problem. So yeah, it's done. So let me run this, and let me run this split. Okay, so it will take a few seconds. Then we can check the size. Okay, now let's check the size of training data. Okay, so there are 4,000 training samples, and it is showing that there is 4,000 training samples. It is a single layer, means it is like the each of the frame is a single layer. Then the size is 32 by 32 by 32, and you can see number of training, 4,000 training samples, and number of test samples, there are 1,000 test samples. So let me give this parameters and all these parameters. So you give it, and then this is the model, so you just run this model. It will take some time to compile, and then you train it. Okay, so training may take some time, and meanwhile I'll pause this video. So training takes place, and once the training is complete, we can see the result, and then we'll move into action recognition using, by modifying this little bit, not little bit, quite a bit. We are just going to use his concept, and we are going to use our videos to recognize the actions, and we'll be using a KTH action recognition. So this is nothing but, as I in previous videos you see, it will take some time to run this. It's actually trying to access the GPU. Once it is done, the compilation will be done. Okay, So once my model has been compiled, I will run this command for training. So it is 100 epochs. It may take some time, so I'll wait for the first example, then I'll pause the video and let's see. Okay, it's taking quite a time. Come on. Okay, so maybe I'll pause the video, I'll not make it longer, and once the training gets complete, I'll get back to you. So it's actually there are 4,000 samples for training and 1,000 samples for validating, and you can see it's taking around 480 seconds, so it's going to take a long time. And also I am sensing some unusual performance here, but actually I haven't tried this code before, means running on his dataset. So I don't know, maybe I've tried earlier, I don't remember, and I'm getting this unusual behavior. So this is not a motive, so you can check this code at your own system and see how you can like manipulate it or do something to get better performance. I'll stop it. I just wanted to show you what examples he has used. He has used for shapes, two different shapes, and he has what to say, perform 3D convolution. But our aim is to do the action recognition, and for that I have written a code here, and we can go here. Okay, so we have tested the example given by Minhas Plasara. Now we'll implement the 3D convolution neural network for action recognition. So for any of the network we need a dataset. So we are going to use a KTH action dataset. It's a very famous and standard dataset, and you can get it from this site, and I'll give you all those links in the video below, so you can easily, you not search for them, you can go to it. So you can get this KTH. You just simply type KTH action dataset, go to first link, and you can get this. So there are 6 actions here: walking, jogging, running, boxing, hand waving, and hand clapping. So you download this and you keep it in one folder. So I have created a new project for KTH dataset action, and this all are covered in earlier videos, how to create new projects and all this. You can go and revise it. And so in KTH dataset I have 6 actions, and I have written a code here, KTH recognition.py. So actually it is nothing similar to this code. I mean, we are just using their framework, actually their library, because they would have configured somehow to run this network, and we will use this kind of network, but you will use a different dataset and different way of entering the dataset. So this is the code. Let me zoom little bit. Okay, and I'll give this code in my blog, and I'll give the link of the blog so you can access this code also. So these are all the libraries that we need to import. And yeah, one important thing that I want to let you know is we are going to use opencv here, since till now we haven't used opencv, but we are going to use cv2 opencv. I have installed opencv 3, and we are going to use this for video processing. So however, for there is a catch in when there will be some error when you try to simply access the videos and all through this. So you need to download something more. So I'll show you this actually. So you need to install opencv, and then you have to copy. Actually, you go to any site for how to opencv python site, and you can get how to like configure your python environment for opencv. But for getting your video processing and all, you have to also install ffmpeg, and you have to set some path. So this is the link of a blog which I got, which will tell you how to configure it. I'll show you. Okay, so this is the blog. So you go to this link and you go this one. Okay, installing opencv and ffmpeg on windows. Okay, so you have to follow whatever instruction they give you, and you have to give this the path and all. Then this, so I haven't shown the installation process here because of some time limit, but you follow this blog and you make sure you get this working, because once only when you get this thing working, you'll be able to use CV2 here for video processing. Okay, so maybe I'll make the video later on that, or you can follow it on net somewhere. Okay, so you need to import all this. Also you need to import CV2, and I am using an image size of 16 by 16. You can use any. Actually this is not that it will give a very good result. I'm just showing you example how you can modify it or use it for your data set and your problem. So I have giving a rows and columns 16 cross 16, and image depth, actually I mean here number of frames. So I'm going to use 15 frames for the each video, and this is a variable that will store all the input videos from all the action classes. There are 6 action classes. This is going to store everything. So I'm going to use this command to read the boxing data set, and this is the code which will read 15 frames, and then it will resize the frames into 16 by 16 size, and it will convert it into a single channel, and then it will append. Actually this is another variable for storing 15 frames here. This is for storing all those actions, and this is for just what to say each of the videos. So this will append it. You can understand this code, it's not tough. So you can append in this variable, and then you can convert the whatever frames you read into form of array. Then you can change this axis, and then you can append it to the input. Okay, so let me run one and show you. Let me run this first. Okay, so you run this, it will take some time. Need not worry, I'll give this code, and so you can slowly access it and understand it, and if you have any doubt you can comment below. So run, and here you can use your own data set. I have used it for my problem, and you need not necessarily use KTH, you can use any data set. This format will actually is quite easy, it will help you. So okay, okay, so let me read this image row, image column, and image depth, and let me read this variable first. Okay, okay, so let me read the first directory of boxing, and let me actually I'm appending here, you see let me read it slowly one by one. So let me read this first directory. So okay, actually I haven't specified the I'm running cell by cell. Let me run this whole. I'll make an error intentionally so that I get the working directory here. So okay, so I'll remove this error. Now my working directory is same as where my data is present. So now if I run this, okay, so in variable you can see listing, there are 99, actually there are 100, one was erroneous, so I deleted it, and you can see this is the boxing class. Okay, so let me read this and append it here. So it will read all this frames. Okay, so now you can see what is the input shape. So input shape is 15 frames, 16 by 16, but I want it in the format of image row into image column into image depth. So I'll rotate this axis by this command, and when now I see the input shape, it's 16 cross 16 cross 15. So this whatever one this set of videos I have read from one action classes, I will append it to this variable which will be storing all the action classes. So I'll use this command. So similarly I am going to do it for all the remaining of my 5 classes. So same process I am going to adopt. Okay, so up to here is the 6 action classes. Okay, so it will run. So once you have got all your frames which are appended in xtr variable, we'll convert it into array, and then we'll assign labels to each of the 6 action classes. Okay, so it's still running, there are a lot of videos. Okay, taking some time. So there are 100 in each cases, except in one case I took 99. Okay, so okay, once I'm done with this, I'll convert it into array, and then you can see number of samples here. So there are 500. Okay, actually I'm taking 100. So there are 500 samples, okay, of all this action classes. And okay, it should not be 5, it should be 6. So actually it should have been around 5. Actually previously you see there is 500, but actually it used to be 6. It has to be 600 because there are 100 in each cases. So actually I missed one of the example. So on rerunning it, I get that there are 598 total video samples. Actually there should be 599 because 0 to 600, so oh sorry, 1 to 600 turns to be 0 to 599, but I am skipping one video because of erroneous video, as I told you before. So there are total of 598 samples, and now we'll assign a label to each of those samples. And with this command you can assign samples. I'm starting from 0 to 5. So my boxing is 0, hand clapping is 1, hand waving is 2, jogging 3, running 4, and walking 5. So once I've assigned label, I will just try to compile the label and the training data together, and then you can rename it and you can see it. Okay, so it's 598 16 cross 16 cross 15, but it has to be a format of this, as the example we saw here. Their shape was in, what to say, number of examples comma number of channel comma image row comma image column comma depth. So we'll convert it into their format so we can feed into the network. So we'll use this as training set. So it is now converted in that shape of number of samples, 1 comma image row comma image column, and then we'll assign all this data set to this. So let me run this for this. So now we are ready with our data set. Our patch size is 15, and you can see the shape of our training set. It's 598 comma 16 comma 16 comma 15. Okay, if we can see the train set, that would be better. Actually I get X train set, maybe train set. Okay, so this is 598 number of image video samples, channel, each one I'm using a single channel, rows, columns, and the depth. Okay, so I'm using a batch size of 1 here, or you can make it 2. And actually these all parameters you have to tune it for your problem. Okay, this I'm just showing one example. Number of classes 6, number of, let me reduce number of epoch, I don't have much time, let me make it 50 maybe. The number of classes are 6, number of epoch, and this one will be used for converting into one hotkey format, which we did previously for 2D CNN. And this number of filters, pooling, and convolution layer, I've used a size of 5 cross 5. This all depends on you, what parameter you are going to use for your problem, and this you have to give a trial and error. So now the pre-processing I'll do is I'll convert them in a float format, then I will do a mean subtraction and then normalization. This will actually help in convergence of my algorithm. So there they have used a 2 convolution pooling unit. Here I am using a single convolution pooling unit. Let me load this model. So I'm loading this model. Once the model gets loaded, I can then run my network. So this part you will have little problem, not problem, you have to understand what I'm doing here. I'm reading each of the directory, I'm reading each of the video, and then you'll get it. It's no, it's not tough. Okay, so let me get, I have load my model, and so now I can split the dataset into a training test dataset. I'll use a 20%, and I've given random state 4. Actually we used to give random state any value of random state, so that every time we divide, it divides in the same manner. Let me split it. Okay, now let me train it using this command, and we'll start training. Okay, so it's training, and there are 50 epochs, so it may take some time. So I'll get back to you when training completes. Okay, you see I have already trained my network, and I trained it for 50 epochs, and at the end of the epochs you can see I had a training loss of 0.6721, an accuracy of 74%, and a validation loss of 0.93, and a validation accuracy of 0.633. So the network is performing quite bad, you can see. but that is not my motive here to give you a very good action recognition model. I just wanted to give you a starting code where you can work on it and improve it, and you can work on your problems. So once you have finished training, you can check. You can already see here. I don't have any explicit test data set, so I can just run it on the validation set which I splitted earlier. You can prepare your own three different data set and train validate it on different set and test it on a different set, and you can see the test score and test accuracy. So this all are similar to the 2D checking all these results. So you can see it's a very bad, only 63%, and we need to change many parameters maybe, or the input which we are taking, we have to take maybe more number of frames, or many things are there. So you can visualize this plot. You remember how to visualize it, and you can see network is the blue color is your training and green is your validation loss, and this is the accuracy. So I hope you got little idea of how you can run your own videos into a 3D CNN model and trained your set of problems and solve it. So this was it, and the codes I'll give it below, and you can refer it, and you can analyze it, read it, and you can change it and use as per your problem. So that would be all, and good luck.